Hello, good day, everyone. I have a physics question here and moments, which says the diagram below shows a uniform meter rule pivoted at the 75 centimeter mark. So this is a pivot here, and of course, it's being supported by the 2 Newton force and the W force here. So it says find the moment of the 2 Newton force above the pivot and also find the W. So without wasting much of the time, how do we find moment? How do we define moment? So moment is the product of the force and the perpendicularity distance from the point of application, which is called the pivot. So it's the product of the force, which is this one here, and the perpendicular distance. So the force is going like this. This is the force. Something which is perpendicular to this force, it will go in that direction. It will be like that. So this is the distance from there to there. The D is what we are looking for. I get the concept, right? So our force is 2 newtons multiplied by our distance is the distance between 95 and 75. Remember we said from the pivot. So it's 95 minus 75. These are centimeters. In order to get, you get 2 newtons multiplied by 20 centimeters. Now remember, distance should always be in meters. So what we're going to do, we're going to divide this by 100. By 100 centimeters, then we multiply by what? By meter. So as to convert these centimeters into meter, because we know that 1 meter is equal to 100 centimeters. So just divide there. So eventually, we're getting 2 newtons we multiply by 0.2. Okay. And our final answer, moment, is just equal to 0.4 Newton meter. That is the answer. It further says find W. Now to find W, we are going to use what we call the principles of moment. We are going to use what? The principles of moment. Now, what does the principle of moment state? It states that the sum of anticlockwise, okay, moments is equal to the sum of clockwise moments. So this force is going in that direction, which is clockwise, and this force is going in that direction, which is anti-clockwise. So the sum of these are just equal to each other, because at the end of the day we are saying it's a uniform meter. That means it's in equilibrium, it is balanced. So how do we do that? So to do this, follow me. So principles of moment, so we are going to say force 1 multiplied by distance 1, this should be equal to force 2 multiplied by distance 2. In this case, this part here, okay, represents anti-clockwise, and this distance here represents clockwise. So we go back. This is our anti-clockwise direction, and this is our clockwise direction. So the moment of this force, so this is our W, and we need the distance from there to there. And which will be 65, I guess, right? Yes. So let's go. So our F1 is just W. Our D1, remember, is 65. Now, Whenever something has balanced, there's no need of converting distance into meters because it's a balanced stuff. So 65 centimeters equal to force 2 is 2 newtons multiplied by 20. Remember I said 20 centimeters, right? Like I said, this is an equation. Things have balanced. Even if you convert the distance into meters, the answers to come out the same. Unless when you are working with one direction, it's unless anti-clockwise or clockwise. So from here you can clearly see that W will just equal to the product of 40, of 2 and 20, which is 40 Newton centimeter over 65 centimeter, in which centimeter will cancel. And our final answer will be just 40 divided by 65, which I'm getting W to be equal to 0.61. I'll just round it off, let's say 4 newtons, like that. And it is as simple as that. So thank you so much for following me in this video on previous Twitter. For online classes, we are available. And you also don't forget to follow us on TikTok and Facebook, as well as subscribe to our YouTube channel.